Welcome to the Explainer. Okay, so today we're unpacking a really fascinating and honestly kind of alarming collision between abstract technology and harsh physical reality. We spend so much time talking about the cloud as if it's this magical, untouchable space just floating above us. But recently, a major incident completely shattered that illusion. It was a massive wake-up call for the tech world that the cloud actually lives in very real, very vulnerable buildings. So let's dive right in and see exactly what happens when geopolitics and physics crash straight into your digital infrastructure. Look at this quote because it absolutely nails what happened when an Amazon Web Services data center in the United Arab Emirates went down. The cloud is sold as abstraction, then something physical hits a building and the illusion collapses. Now, the headlines were pretty wild. People were talking about missile strikes and massive fires, and while AWS didn't confirm the exact geopolitical cause, they did officially report that objects struck their ME-Central 1 facility. Boom, just like that, the weightless, untouchable cloud wasn't so weightless anymore. The thing is, we love to hide behind this comforting cloud vocabulary. We talk about regions, availability zones, APIs, replicas. It sounds so clean, right? Almost mathematical. But the physical reality? It is heavy, literally. A cloud region is actually made of tons of concrete, massive substations, cooling plants, and huge diesel generators. When that illusion drops, you aren't managing an API anymore. You're suddenly entirely dependent on local fire response teams and physical hardware. Which brings us to our first big takeaway. Physics completely overpowers the dashboard. What unfolded in the UAE is basically a masterclass in how physical safety protocols will override your IT priorities every single time. Let's walk through the timeline of the actual incident because it's incredibly telling. Step 1, objects strike the facility. Step 2, this causes sparks and fire. But step 3, and this is the absolute kicker, the local fire department arrives and immediately shuts off the power and the generators. They have to, right? It's for safety. And because of that, we hit step 4, recovery stretches for more than a day. Look, your priority might be getting your app back online, but the fire department's priority is making sure the building doesn't burn to the ground. Physics and safety win, every time. Now, of course, the internet did what the internet does and reacted with immediate clickbait. People were screaming, "Amazon is on fire. Everything burned down." But the technical reality was far more precise. It was sparks and fire led to a power shutdown. The tech community rightfully critiqued those dramatic headlines, and it's a super important distinction. Precision matters here. Exaggerating the damage kind of muddies the real lesson. The technical reality is totally serious enough without making things up. A major cloud availability zone was taken offline by a physical impact. And that leads us to a pretty harsh truth. The dashboard can recommend recovery plans. The building has to obey physics and local authorities. There's a brutal hierarchy at play. It really doesn't matter how mission critical your workloads are or what your AWS control panel says. Nobody gets to just wish the power back into a damaged data center while emergency crews are still deciding if the floor is safe to walk on. Okay, zooming out from that single building, let's talk about geography as a hidden SLA, specifically the physical layer risks on a global map. For years, cloud providers have been pushing their infrastructure closer and closer to customers to reduce latency, make it faster. But pushing closer to the customer brings inherited geographic risks. When you build in certain regions, whether it's the Middle East or honestly anywhere else with geopolitical friction, you adopt local risks. Missiles, drones, civil unrest, government intervention, undersea cable issues. You aren't just renting compute power, you are inherently adopting the physical and political realities of that specific landmass. So here is the bottom line. A region is not just about taxes and latency. It's a bundle of risks. Building in places like the Gulf makes perfect business sense for demand and connectivity. But as customers, we have to stop treating every single cloud region as if they're perfectly interchangeable Lego bricks. They aren't. Some regions come with the risk of hurricanes. Others come with the risk of military escalation. Check this out. During the outage, this exact question popped up in the community forums. Is the Bahrain data center affected too? And I think that perfectly captures how regional outages spread anxiety. The physical damage was totally localized to the UAE, but customers instantly started mapping their dependencies. Wait, where's my backup? Which fiber route am I actually on? Suddenly, your nice, neat little cloud architecture diagram turns into a very tense geopolitical map. So, what happens when that map lights up red? Let's look at the ultimate disaster recovery test, where theory crashes into reality. As one commenter grimly joked during the outage, time to test your DR plan. It's funny, but, it's a dark kind of funny. Everyone claims to have a disaster recovery plan. You probably have a beautiful, color-coded diagram of it somewhere.
But this outage forced operators to confront the massive gap between their theoretical resilience and whether they could actually press a button and keep their business alive under real pressure.
Let's break down exactly why. Lots of folks rely on a multi-AZ architecture, meaning multiple availability zones within the same region. But as we just saw, multi-AZ is incredibly vulnerable if a physical event compromises shared regional power, local authorities, or the regional control plane. To survive a physical shock to an entire geography, you absolutely need multi-region architecture. That means true geographic isolation with remote backups. Now, during the outage, AWS actually advised customers to failover to an alternate region like Europe. But the reality of remote failover is brutal. It means higher latency. It's significantly more expensive. It's operationally annoying. Actually, scratch that. It's downright terrifying because testing it risks breaking your actual production environment. This is exactly why teams put off this incredibly inconvenient practice until a physical disaster literally forces their hand. When an outage like this removes all your excuses, the tech community immediately splits into three very distinct camps. Camp 1, the prepared. They grumble about the work, but they execute their remote failover and they recover. Camp 2, the semi-prepared. They try to failover and immediately discover exactly which part of their beautiful DR document was total fiction. And then, Camp 3, the unprepared. They just sit there, stare at the red dashboard, and pray for the fire department to finish their job. Moving to our final point, the new critical infrastructure. We have to fundamentally reframe how we view these massive server halls. Data centers are no longer just places that host cat blogs and static websites. Consider what they host today: financial systems, government services, health platforms, global logistics, massive AI workloads. Because they host enormous foundational pieces of our daily lives, placing them in regions with rising military or political tension elevates them from simple commercial buildings to strategic nation-state level assets. They are officially part of the geopolitical map. Someone in the comments actually joked that Amazon was going to have to start installing prime air defense batteries in their parking lots. And yeah, it's a dark joke for sure, but it points out something profound. Treating data centers with the exact same level of physical security and strategic importance as we do international airports or nuclear power plants, honestly, that is no longer an absurd thought. I really want to leave you with this amazing summary from the source material. The cloud did not disappear. It became real. And real things can burn, flood, and lose power. The promise of cloud computing was never that bad things won't happen. That's impossible. The promise is that we have the tools to design systems that can survive when they do. But that survival absolutely requires acknowledging that geopolitics can and will reach all the way down to the physical layer. So here's what you need to take away from this explainer. A dashboard can tell you what went wrong, but it absolutely cannot build the disaster recovery plan that you skipped. Take a hard look at your architecture today. Ask yourself, are you entirely dependent on one physical region? Are you truly ready for when your cloud gets physical? Thank you so much for joining me for this deep dive. Keep learning, keep questioning those dependencies, and I'll see you on the next explainer.